Okay, boys and girls, last question of the paper, which will be the most difficult one of the whole exam. It is often the question that most candidates completely ignore. And it is the question that if you want to get an A grade for this course, it's one you have to attempt, or at least try to attempt. It's a task that you do in the assignment when you have done your Yenka simulation, similar to the diagram to the left here, circuit diagram, and you need to convert that diagram to a strip board layout diagram like the one on the right here, in order for you to then actually physically build the circuit. Okay, now to approach this type of question, it can either be in various different styles. They can go from circuit to strip board, from strip board to circuit, from PCB to strip board, or strip board back to PCB. Now I'm going to do a series of videos with this type of question. At the moment, the style that I want you to focus on is circuit diagram to strip board. Okay, not going to do any other styles at this moment in time, so that maybe gives you a hint about the upcoming December exams. So, here's the question. For the circuit diagram shown, complete the layout diagram. Now, what I've done here is I've actually split my screen and I've got the same paper up, but I've split it on two sides because this is a type of question you need to really sit down with it in front of you. If it's on two separate pages, you really actually want to... They will put the layout diagram and the circuit diagram on the same page. This year, the specimen paper, when they done this, they split it between two pages and it was a nightmare because you were flipping back from one page to another. You really need the two side by side. What you also need as well, depending on the question, is your data sheet, because your data sheet contains your IC pin out diagrams for a 741 op-amp and a 555 timer, and also the pin layouts for your gates. Now, in this question here, we don't have any IC chips. We have a transistor in here, okay? And what they do in the exam is they help you by actually putting in the first component on the strip board diagram here on the right. So let me just talk you through this strip board diagram on the right here. We have your voltage supply, which is equivalent to this here. Hold on, let me just get my on both, right? We also have our ground also indicated in here. So what that's telling us is that, see this top line here, right along here, that line going along, and what I'll do is, let's take my highlighter. I'm going to try and make this as easy to understand as I possibly can. That top line there is your voltage supply line here. Okay, and then what I'm going to do is I'll go for, normally I'd go black, I'll go grey, okay, just to make it easy to understand. And that bottom line there is your ground supply, okay? That's your first to understand. Next, we have two different layouts for a transistor. We have a circuit diagram 1 and a strip board layout diagram 1. Now, 9 times out of 10, you just take the exact same symbol that's on the circuit diagram and put that onto the layout diagram, okay? If you do wish to change it, you can, but make sure you use the correct symbol, okay? So, how are we going to start this, Mr. Bell? Well, first of all, I'm actually going to label my transistor here. Base, collector, emitter, okay? And you got to methodically go through this. So what you do is you're going to take each component one by one and think, where is that component going from each row, okay? So to start this, I'm going to start at feeding out from the transistor, the main component. If it was an IC chip, I would start to feed out from all the pins. So what's happening? From the emitter, I have got a resistor that goes from here down to ground. So anywhere on this line here, right, I can put my resistor. Now I'm going to just be logical here and put it to the right. You can put it anywhere. You could start it from there, anywhere along that row. Okay, when the marker actually marks this, they've got to take it methodically per component. Sometimes the markers just hope that you don't attempt it and like easy 0 marks, but you lot are all going to attempt this. So going from here, I'm going to put a small dot in, and I want to do it black. I'm going to do it here, small dot, and then I'm going to draw the component in. So it's a resistor, so it's going to be a rectangle like this, and I'm going to draw that in, and it's going down to the ground. Put a wee dot just to indicate that that's where it's going in. Okay, and then I'm going to label it R2. Okay, that's all you need to put in. You don't need to put in 1 kilo ohm, 0.25 watt. You just put in R2. All right, so let's take the highlighter, and I'm going to highlight that one as complete. Okay, in the exam, what you could do is you could score out on the actual diagram. Okay, that part done, this part done, this part done. Okay, next one, we have got a buzzer. Okay, now the symbol for a buzzer on a strip board layout diagram is exactly the same as shown here. Okay, so what I'm going to do is I'm going to take my black pencil, and I'm going to take it from anywhere in this line. Let's say I'm going to take it from here. Okay, and it's going to go up to the voltage supply. Okay, and then all I'm going to do is I'm going to draw in the buzzer. So when you get a buzzer, let's get this. When you draw a buzzer in, I'm going to put a slight. It looks basically like a cauldron, but down at an angle. Okay, now from that I'm going to feed out lines. It's going to go there. I'm going to feed a line that goes there. Okay, so there's my buzzer. Okay, and you could put in a symbol for the buzzer, or you could write in buzzer as if you were labeling it. Remember, when you labelled your circuits, you would always have labelled everything on the strip board itself, the labelling machine. So that's that one done. Okay, highlighting it. The actual transistor has been done for you, so you could in theory highlight the transistor. Okay, right, next we have an LDR indicated here. Let me get my pointer. So we've got this LDR here. Okay, this needs to go in. It is coming from the base, so it's on that row. Okay, right, so this row here, if I'm going to highlight it just to make it easier for you, let's put it in green. That row there is basically this row here. And that row runs all the way along. Okay, you get me? Right, so colour is key here. I'm trying to explain this. Right, so the LDR, right, we're going to draw that in. Now, I would have just drawn it in as exactly as it is in the circuit diagram. Okay, I know there is alternative ways of drawing an LDR. I'm just going to put it in exactly as it is in the circuit diagram. Now, where does it go from? It goes from here. Now, we've got another component, the resistor R1, that's going to be in this same row. So I'm going to put it further to the left here. So there we go. And it's going up to the voltage supply here. Put in our arrows. And then we'll write it. Put our lines in. And then LDR. Okay. Get me so far? Right, then I can highlight that to indicate that I've done that one. And the last component here is R1. So R1, I'm going to put in, it's got to go after the LDR but before the base. So anywhere, could be here, here, could be, it could be any of these points. So it could be there. You could put one candidate might put it in there, there, or there. It's up to yourself. You choose. And there's your dot, and that's going down to the 0 volt. Now, sometimes you find that you've got to put in wires to stretch a component. I mean, you could run a resistor from there straight down to the bottom. In practice, when you're doing your assignment, you wouldn't do that because you're stretching it too far across. So what I'm going to do is I'm going to add in a wire, and that's allowed. You just need to be careful how you do it. So say, for instance, I run it to this row here. Indicate that, this row here, right, okay? Nothing is getting used in that row. It's not interfering with this side of the circuit. So I could do that. And then if I label that R1, but I then need to put in a wire to run it straight down to ground, okay? I'm trying to make this as realistic to the real world as it is, because obviously in your assignment, when you do this, you're going to have to add in wires as well, because stretching components that far is a good bit. You could have done the same with R2, okay? When you have done that, you then go back to your original diagram and you methodically go through it and take it component by component, location by location, always working from that center item, okay? And it's either going to be something like a transistor or an IC pin. I'm going to do another video on this with different circuits to get you to practice, okay?